Hello, everyone, and welcome. We are going to talk about machine learning basics. We will start with a lesson on the difference between AI and machine learning. So, what really is the difference? Artificial intelligence, as a term, refers to the design and study of systems that appear to demonstrate intelligent behavior. And the keyword here is appear. It is a set of technologies that have been implemented in a system that enables this system to appear like it's reasoning, and it's also learning and acting in a way that allows it to solve a complex problem. These systems are built to mimic what we humans do, how we perform tasks, and how we do things in general. Think of it as an umbrella term for creating systems that appear to be intelligent overall. If we have to give a couple of examples of what this might look like in practice, it could be things like self-driving cars, it could be things like automated voice assistants, Alexa or Siri, and it could be things like recommender systems, like what you get in Spotify or what you get in Netflix. These systems combine multiple different machine learning models, as well as rule-based systems, as well as visual recognition, as well as connection to hardware in most cases as well. So multiple different things need to happen in tandem in order for these systems to appear like they're completing a task and they are mimicking human intelligence. And again, key thing here is appear. On the other hand, machine learning is a subset of AI. It is a very specific approach to building AI applications where the models are trained to make predictions. Essentially, machine learning models learn from the data that you provide to them in order to determine what the correct output is for a very specific task. For instance, you might want to train a machine learning model to recognize whether an email is spam or whether it is a genuine email. You might also want to train a machine learning model to classify your content, whether it is blog post or whether it is a news article or just a thought piece, for instance, or classifying based on topics and so on. In summary, machine learning models, as you can probably tell, are a lot more laser focused on the specific tasks, but they are always working with data. They are always working to make a prediction based on the data that they have been trained on, and they are working to achieve very narrow tasks. Examples of machine learning models could be classification models, it could be generative AI models as well, which means, of course, generative AI is, again, a prediction-based model. It's making predictions on what the appropriate response to your query is based on the data that it has been trained with. So the bottom line here is that while AI is about creating entire systems that exhibit human intelligence, or at least try to mimic it to the best of their ability, machine learning is a very specific technique or tools that are used. Of course, it falls within the AI umbrella, but these are models that often work in tandem to make AI systems. And artificial intelligence is an overarching term that covers a wide variety of specific approaches and algorithms, including such that are related to software, but also such that are related to hardware. While machine learning sits under that umbrella, it is primarily, if not entirely, software related. But of course, as part of the AI field, we do have other major subfields like robotics or computer vision systems that integrate with cameras, or autonomous drone technology, or AI-powered sensors for smart devices and things like that. To set expectations, that's why it's titled machine learning for SEOs as opposed to AI for SEOs, even though, of course, machine learning is part of AI and you are learning how to use these tools, but we will only be using machine learning models in isolation to complete tasks. And so we will focus on understanding and using models that are trained to make predictions, and that will be simple, practical, and actionable applications of machine learning in SEO and organic search marketing. Now, you might hear terms like AI, machine learning, deep learning, or data science being used interchangeably. In reality, they represent distinct but somewhat overlapping concepts. Deep learning, for instance, is a subset of machine learning, while data science overlaps with machine learning, but it also has a broader scope that is related to mathematics and statistics, data analysis, visualization, and so on, often concepts that don't at all relate to machine learning and AI. And if we have to talk about where generative AI fits into the picture, it's right here. It's within deep learning, part of machine learning, and it has, of course, gotten a lot of attention over the past few years. If you're wondering where LLM-based chatbots like ChatGPT or Gemini, they're just a small section of this whole field, even though on platforms like LinkedIn or X, you might find that generative AI is the most talked about AI application. That is not in reality the case. It is a very small subset, even though it has been getting a lot of investments over the past few years. It is not the most profitable. It is not the most widespread. It is not the model or the field of AI that is getting the widest return of investment. So it's just a small section of this field of AI technologies. I wanted to also talk to you a little bit about the development of AI and machine learning and how these two concepts came about. So artificial intelligence has been around for a long time, since the 60s. Some early pioneers like Alan Turing envisioned machines being capable of thinking and solving problems just like humans do. Initial systems really relied on symbolic logic and being rule-based and handcrafted algorithms. Despite the early promise that these models showed, they didn't really have any adaptability or any ability to learn from data. And this led to what we now know is the first AI winter, which was the result of limited computing power, which ultimately led to a lack of understanding of these machines on how to make the decisions that they were tasked to make. I do have a separate article on AI winters if you're interested in more of this, but in the spirit of moving on with this lesson, I'll leave you to dig into it if you are interested. When we talk about machine learning as a subset and when it became popular, it was around the 90s and early 2000s, which was when researchers were focused very much on big data analytics and the fact that a lot of bigger data sets became digitized thanks to the internet and thanks to efforts in digitizing data and thanks to digital storage as well. That was the driving factors alongside the creation of more computing power and chips like GPUs, for instance, which actually led to the boom of machine learning as a subfield of AI. Early machine learning models were quite simplistic, like decision trees, support vector machines, but they started delivering much better performance on specific tasks like classification and regression. But the real breakthrough in machine learning came with the advent of what we now know as deep learning, which was specifically influenced by the introduction of neural networks around 2010, which could process unstructured data formats like images and text, which is what we will work with the most throughout this course. So the real transformation that we are seeing in the current age is the fact that we now have the ability to build systems that combine multiple different machine learning models into different architectures, like ensemble methods, hybrid architectures, or integrated AI pipelines, and most recently also the development of AI agents. This allows automated systems to solve even more complex tasks for us with minimal human intervention. So let's unpack a little bit more and summarize the key differences between artificial intelligence and machine learning. I have a table here with the main differences. The key things that I would like you to focus on that the data differs between the two. Artificial intelligence can work with structured, semi-structured, unstructured data, whereas machine learning primarily uses structured or semi-structured data. But of course, with the recent developments in machine learning models and GPUs, we are seeing now more and more models work with unstructured data as well. Most of what you see in terms of AI systems are ensembles of machine learning models combined with other functionalities, whereas most machine learning models have a very narrow way of working. They are focused on self-correction and improvement through exposure to new data only if they have these type of capabilities integrated into the machine learning model itself. And they are based on statistics, mathematics, optimization, adaptation as well, whereas artificial intelligence combines all of these models, but also integrates things like context or logic, rule-based approaches, and so on. If we have to put things into context, when we look at Google, for instance, we know that Google has been, of course, at the forefront of development of machine learning technologies since their very inception. So here are some models that Google has developed throughout the years. The first one is Google's BERT, bidirectional encoder representations from transformers model, which is a language model that they introduced in 2018, which has been heavily integrated in many of the systems that we now know. It's a model for understanding unstructured text and actually extracting insights from that text. Another example that was more recently introduced in 2021 is the multitask unified model, which is very similar to BERT, but it combines the ability to extract insights from multiple formats of data. and it uses a more powerful framework to understand language, but also to generate language as well. Another example is Google's Gemini, which was introduced very recently over the past few years during the boom in large language models, and it serves as a successor to several other models that they developed in the past, like Lambda and Palm 2. And of course, this is a large language generative AI model. Now, an example of an AI system that Google has is the system that mimics human intelligence, which is actually Google's search ranking system. They have a guide on the ranking system and all of the different models that it combines. And it combines different machine learning models like BERT, like MUM. It also combines different approaches to handling data like information retrieval, ranking, and so on. So it is a complete system that we could say it is an AI system because it is an automated system that works and combines in tandem several different machine learning models, several different logic and ontologies and ways of processing data in order to create a ranking. That is what we would expect in the past a human to do if we were to go search in a library, for instance. This actually lovely graphic is from an article by Mario Fisher on how Google search works, which I would highly recommend for you to check out because it also shows the different data points that they use or that they're rumored to use, because of course we don't know with certainty, but it is a very interesting way to look at how this system works. So why this lesson? Why does it matter for you to know the distinction between AI and machine learning? This distinction is critical because AI, especially at the moment, it is presented as a magic box, or most recently like a get rich quick scheme or get traffic quickly using AI scheme. And especially in the current era of AI hype, understanding the distinction and using the correct terminology when searching is going to make it a lot more easier for you to find the appropriate solutions for automating the workflows that you would like to automate. And it will make a world of difference whenever you use the appropriate terminology. Knowing the role of machine learning within the field of AI will also help you to ask better questions whenever you are searching for models, but it will also help you to better articulate and set realistic expectations to your stakeholders of what AI can do within the process of automating different tasks when it comes to marketing. It also actually challenges you to be more precise in the way you speak and how you search for, how you find, and how you present machine learning enabled automation for the projects that you're working on. Okay, so now that you understand the difference between AI and machine learning, we will start exploring applications of machine learning in SEO. Before that, in the next lessons, we will go over the characteristics of machine learning tasks, data, and solutions before wrapping up this section with practical ways to search for and find machine learning enabled solutions for different workflows that you might have in SEO. Thank you so much for watching this lesson, and I'll see you in the next one.